All right, so it says consider the function f is equal to the log of x. All right, and then we have three transformations on the screen that they want us to do. So I don't know. Let's try to do this by hand. So h of x, is 3 times whatever f of x is minus 3. So what you can do, there's no plus or minus inside the parentheses, so we're not shifting left or right. But we are multiplying the y value by 3, and we'll talk about that in a second. But this number outside of the parentheses, this is the vertical shift, and so it's going to go down 3, but we're multiplying by 3. So let me give you an example. So if I look right here, when x equals 3, on f of x, y equals a half. So I'm going to multiply that by 3. So I'm going to say 1, 2, right, 1 half. So I'm going to get 3 halves. So I should be here. But now I'm going to shift down 3 units. So remember, 2 ticks is a unit. So this is like 1, okay? And then this is like 2, and this is like 3. So that point's going to be here. All right. Same thing here. This is 0. 0 times 3 is 0, but then I'm going to go down 1, 2, 3, and I'm going to be off the grid a little bit. Over here, same thing. I'm going to multiply this by 3, so that puts me up here, but then I'm going to shift down by 3. So my h of x should sort of look like this, sort of, right? That's how h of x should be. So then what is the domain of h of x? Because they do give us some options. Well, the domain of h is still going to be from 0 to positive infinity. This will approach 0, but it'll never cross 0 because my original function doesn't cross 0. Okay? There's no horizontal shift, so it doesn't cross over. All right? Now, I can verify this by just simply graphing it. So I'm going to take my parent function, which is log of x, and then I'm going to multiply that by 3. So I'm going to say 3 times log of x, and then I'm going to minus 3 on the end of that. So if I look at the graph, see how that looks? Oh, actually, I was off a little bit. It is going to, well, that's at about 10. So, yeah, that's about right. So, well, let me zoom in so it looks exactly, because I'll take a screenshot of this. So if I zoom in on this, let me set my window from x to 10 and negative, it looks like, what is it? Negative 2. What I'm doing is I'm setting up the windows to look exactly like the window here. So this is negative 2, this is positive 2. So I'm going to say negative, negative 2 to positive 2. So now when I graph this, it'll look just like the graph. Okay. All right. So we're good on this one. Now for the next one, for g of x, I'm going to flip this about the x-axis. So this is going to flip, right, because it's negative. So we're going to flip over x. And then this minus 3 means we're going to shift. It's inside the parentheses, so this is a horizontal shift. 3 units to the right. Okay, so for example, this right here would flip across over here, but now I'm going to go over 1, 2, 3, which would be about right here. This one is still on the line, but now it's going to shift over 1, 2, 3. Okay. This one right here would be a positive one over here, but now it's going to shift over 1, 2, 3. Okay. So I should, this will kind of look like, it should kind of look like that, right? So one way to find out is I'm just going to graph it. So I'm going to come in here and I'm going to say the negative, and then I'm going to say log, but now I'm going to say log of x minus 3 and graph it. See how that worked? Now, this line goes on forever up this way, but the calculator struggles with it. So anyways, how I have it drawn is right. So one of the characteristics of that is that it has a vertical asymptote at x equals 3. It's never going to cross this x equals 3 line. Never. Ever, ever, ever. Okay? And lastly, let's do the last one. I've done red, I've done green, we'll try yellow. So for the last one, this is not flipped at all. We're just sliding everything over 3 units to the left, right? If it's inside the parentheses, 3 units. So this is pretty easy. I could pick this point right here and just go over 3 units. So 1, 2, 3, it's going to be like over here somewhere. From this point, I'm going to say 1, 2, 3. From this point, I'm going to say 1, 2, 3. From this point, I'm going to say 1, 2, 3. And so my graph should look sort of like that. Okay. Actually, my curve is a little bit off. And so I could graph that and check. So basically what I'm going to do is I'm going to come in here and I'm going to say log Let me change these so the colors match. So now I'm just going to say log of x plus 3 in the parentheses, which is a horizontal shift. So there's my parent function f of x. Next comes my h of x and then g of x. And then there comes that last function. I don't know what that is. What is that? Is that another f of x or j of x? I don't know what it is. So let's take a picture of that. Then what property is that going to have? Well, that's just going to have an x-intercept of -2, -2 comma 0. All right, so right here, that property is going to have an x-intercept of -2 comma 0. And so basically, as we were talking about earlier, if we go through and I have data that looks like this, because I know how to transform the parent function, I can make it fit any way that I want or need it to.